Welcome back, everybody. Welcome back to the channel. So today we're going to be doing a little bit of an interesting video. So as I've kind of mentioned before, we're kind of gearing up to be towards the end of building our virtual machine. Now, one thing that I've recently added that I didn't really get a chance to mention is the wait and notify system. So this is a new system that I implemented recently, and I'm just going to kind of go over it. This is something that you're going to want to add in your programming language once you get to building a multi-threading platform. So what is a wait and notify system? A wait and notify system is a way for you to effectively do inter-thread communication. Basically, the concept of it is you have some object, right? So if I scroll up here, actually, I'm going to go to job. So I'm actually going to show you a real life example of how this is going to work in the real world. And then I'm also going to show you guys how I actually implement it at the low level. So imagine we have this class called job. Now job is representing a class that is inside of my support library, and this represents the main class for creating tasks in my task scheduling API. And this job class basically has all the various things we need to control, start, and stop that job. But there's a huge problem with this. So I'm going to go through now. I know I've gone over my job scheduler before, but I've constantly made changes to this multi-threading system. So you're probably going to see some new stuff in here that you haven't seen before. And I just want to go over it for the purposes of this video. So the way that it works is I start up a scheduler, and the scheduler starts up a thread which calls this thread main, or this scheduler main. And this main function, its only and sole job is to loop forever and just schedule a crap ton of jobs. So it's just going to go through the entire list of jobs, and it's going to pull out the scheduled job at the index of I, and it's going to do a series of checks, and I'm not going to go into exactly what it's doing because that's not important for the purposes of this video, but there's a huge problem with this system. So I call this function called execute job, and in short, what this execute job does is it tries to get a host, which effectively all it's doing is it's looking for a host to run on. So I have two types of tasks. I have long-running tasks and short-term tasks, and I have two different thread pools for each task. I'm not going to get into the specifics of that, but just know that there are two different thread pools for each type of task. Now, once I pick which thread group I'm going to be searching, I basically look for a thread that is effectively done with its job. So I have a concept called a host controller. And all the host controller's job is to do is to hold the current job that a specific thread is executing at any given time, and then to also contain the time that the thread was actually last ran. Now I do that for tracking purposes for reasons that are out of the scope of this video, but once we find a host controller where the scheduled job is equal to null, that means that the current thread is inactive. So what I do is I come back down to here and I basically try to start that job. So I call execute async to start that job. Now I'm going to go up here to the job file, and if I scroll up to the top, I can find the execute async function. And now here's where the problem lies in the wait and notify system when it comes to thread synchronization. So what I do is I set up the controller information, when was the last ran, and what's the scheduled job. And then I check to see if the host is active. Now, if the host is not active, that means that the thread currently isn't running, and that's entirely possible. Maybe the user got an exception or whatever. So I'm just going to reuse the same thread. I just restart it basically, and I pass in the job controller for that thread to contain. Now, that means that we have two threads utilizing the exact same object, and that poses a problem when it comes to read and writes of data. So originally what I did was I ended up using the suspend and unsuspend system. There's a huge problem with the suspend and unsuspend system because at any given point, let's say you're creating thousands of these things. That's going to pose a problem for the garbage collector because potentially that can mean we could have a collection during the time that we're trying to execute this job asynchronously, and it could pose hitches. Now, it's not going to completely destroy the system. It's just a very inefficient way of actually solving the problem. So if you want to actually solve it in the best, most efficient way possible, you want to use the notify and wait system. And the basic concept is I want to set the controller's scheduled job equal to whatever I need to, and then I call notify on the controller object. And remember, we have both the scheduler thread and the current thread that we're trying to start up again, both sharing that controller object. So now if I scroll down here, we're going to look at the main method of each job thread. So every time I create a thread to execute a series of jobs, it has this job main, and it's an indefinite for loop that waits for another job to execute. So I basically check to see if the scheduled job is not equal to null as just a safety precaution. I execute the job and I set the job back to null. And then I go back up to the top and wait for the next job to be sent to me via the scheduler's thread. And this is just a great way to basically, again, just say, hey, thread, it's time to wake up because you have more data to be received. So that was a basic high-level look at how the wait and notify system works at the high level to do inter-thread communication. So this wait and notify code is going to represent code inside of the object class. Now, if you guys remember, the object class is inherited by every single class in our programming language. So this ensures that every single class that the user creates will have this wait notify system implemented. So I have a couple different types of things we could do here. So of course, we can wait for some data. We can notify a thread. Now, notify is a blocking call, meaning that, and by the way, all the stuff that I'm going over today, Java also does a very similar thing. So I'm literally just kind of copying what the Java virtual machine is doing, but we basically want to either notify indefinitely. So once this function gets called, if we notify a thread and that thread is not waiting for some data, then we're going to be trying to notify that thread indefinitely and never exiting the scope of this function. So that's where this function comes in, where we can specifically try to notify a specific thread that there is something it needs to do for a specified amount of time. And as you can see, I have some assembly code here to basically do that. Basically, all I do is just push the local, which is, the current object, push local at 0. And if you guys remember, every time you call an instance function, the instance of whatever you're calling is going to be at index of 0. So that's why I'm saying push local of 0. I do that for all of them. And then specifically for this notify, I also load a local of mils into the EBX register, and then I call the respective interrupt to actually do whatever we need to do. Now let's actually go even deeper to see what is happening at the low level. So as you can see, I'm calling these individual values. Now, these numbers you don't really need to pay too much attention to. These are just random values based on where they fell in my switch statement. You guys, if you're going to do this, you're going to probably have different numbers than me, so you don't exactly have to copy these values, but that's going to be inside of, if I go to virtual machine CPP, and then I do a search for system interrupt, and then I go inside of here, and then I do a search for notify. So if I go back here, notify, and as you can see, all I'm doing is literally just popping the object in question off the stack and then calling wait notify or notify with the EBX register. And if you remember, if I go back to object, I'm setting the EBX register here for notify with mils. So I'm calling the respective function based on whatever system interrupt is being called at the time. Now, if I go here in the data structure of object, we have all of these functions. Let's go through each one. You want to make sure that you have both sleepability and interruptibility. Now, I just made up those words. Basically, you want to be able to sleep and interrupt the thread in the process of notifying and or waiting for data. So if you want to kill a thread at the high level and interrupt it, you should be able to do that. So for wait, what I do, and now all these functions are pretty much very similar, it's just with slight variations. So you want to check to see if the object is equal to null. If so, return. That means that we're checking this sharp object here. So obviously there's nothing to wait for or even notify if the object is null, so that obviously doesn't make any sense. And you guys have seen this before. This is all very similar to the multi-threading source code that we've seen in the past. So literally I have an indefinite for loop or while loop where I check to see if the monitor, now this is a new field that I've added, and I use a bit field of 1. because the size of this integer here only needs to be 1 bit wide in order to actually work. So in the wait function, you can see that I'm just waiting until monitor is equal to 1. So I'm saying while monitor is equal to 0, I'm just waiting indefinitely. So I try to bounce around in here in the while loop without sleeping, because you don't want to sleep too much, because potentially it can make your source code a lot slower if I'm sleeping constantly for 1 millisecond. So I spin for 128 times 1024, whatever that value is. And then if I pass that limit, then I say spin count plus plus, which I actually don't think I need to do, so I can actually remove that. So I'm going to remove that code. So I set retry count equal to 0, and then I yield, meaning that I want to try to attempt to give up this time slice provided to me up to another thread to actually run. I sleep, and then I do other checks. Now, the reason why I'm yielding is because, I mean, as you're waiting, you want to give more energy to other threads, because the assumption is that as you're waiting, there is some other thread on the other end that's trying to set this monitor equal to true. And while we're spinning, I'm also going to check to see if we've been killed or if we have a signal tsig kill. And if either of those are true, then I return. Otherwise, if we have a tsig of suspend, meaning that I need to suspend the thread, I suspend the thread inline inside of this function, because as we're waiting, you want the source code to be locked in place and wait indefinitely until something happens. So for instance, if the garbage collector wants to suspend all threads because it needs to do a collection, you can suspend it while inside of this function and just continue waiting for the monitor to equal 1. After that, I also check to see if the VM state is equal to shutdown, meaning that the virtual machine is shut down, and I just basically kill the thread and exit, because obviously the programming language has been shut down completely. After that, I set monitor equal to 0, so I basically reset the monitor, so if I call wait again, I can wait for the next piece of data. Now, when it comes to notify, it's pretty much the same, but with a slight variation. So immediately once I get inside of here, I do my, object null check, and I immediately set the monitor equal to 1, and I wait until the monitor is set to 0. So I say while the monitor is equal to 1, I, do the same thing where I do 128 times 1024, and I spin through here. Otherwise, if I get to that limit, then I sleep, I yield, and then sleep for 1 millisecond. Otherwise, I'm also checking for whether we've been killed, suspended, or shut down. And it's literally the same thing. And once it is set to 0, meaning that it has consumed the notify signal, then I just exit out of this function, and that's it. Now, notify for mills is pretty much the same thing with, again, a slight variation. So I set the base time. So you want to get the current time in nanoseconds as the base value, and then say now is equal to 0. And now is going to be the current time that we're currently in. So what I do is I basically do all of the same stuff, but I set now equal to the current time in nanoseconds minus the base time. And that's going to give how much elapsed. So this is probably a bad name. This should say elapsed milliseconds or elapsed ms. Basically, I'm just calculating the elapsed milliseconds since the start of the function, since I set monitor equal to 1. And if that elapsed time, as long as we are greater than 0, right? So as long as the mils, so if we're trying to wait for 1 millisecond, and now, or the elapsed time, I'm actually going to change this down. I'm going to say elapsed ms. So as long as the current mils minus the elapsed milliseconds is greater than 0, that means that we still have time left. We continue sleeping. Otherwise, if it's less than or equal to 0, I say monitor is equal to 0, and then I break. Basically meaning that I have canceled the notify for that actual object. And that's it. So that's basically how the notify wait system works. Let me know. Hopefully I explained this pretty decent, and if you guys have any questions, as always, put them in the comment section below. And as I mentioned in my Monday video, I am looking to do a live stream this Friday, so I'm still looking to do the 6 o'clock p.m. Central Standard Time. So if that's good, definitely give this video a thumbs up. Otherwise, if that does not work for you, then put it in the comment section below, and I will try to pick the best time. So that's going to be it for today, guys. Hope you enjoyed the video. As usual, if you have any questions, you can always send me an email. That's going to be in the description below. And of course, if you guys would love to help support the channel, you can always head over to the GitHub repository at androidfcd/sharp. When you do, definitely watch, star, and fork this repository. It gives this language a lot more visibility and let other developers know this language exists. Also, if you guys are curious about some of the various things that I've been up to in regards to improving the language, you can always head over to the project section and click roadmap. This is kind of a live real-time view of what I've been up to with the programming language in real time. So I have like a to-do column and progress and done. So this is a nice way to kind of see what I'm up to on the actual programming language. So that's going to be it for today, guys. As usual, if you're new to the channel, definitely consider subscribing. And until next time, I'll see you guys later.